Hello everyone, my name is K. Chinchireddy, working as assistant professor in Tikala Krishna Reddy Engineering College. In this video, I will explain electrical and hybrid vehicle subject. The subject in R18 syllabus JNTU, the R18 syllabus, AAA department. The subject is in BTech 4th year first semester. Okay. In my previous 3 videos, I explained hybrid electrical drivetrains and electrical propulsion unit. Okay, lecture 1 and lecture 2 and lecture 3. I covered 3 topics. This second unit, second part, and the third chapter first part, and the third chapter second part. Now in this video, I will explain fourth chapter. This fourth chapter first part. This fourth chapter first part, energy storage. Next, in this energy storage, mainly 5 types is there. First one, the energy storage. This chapter, introduction to energy storage requirements in hybrid and electrical vehicles. This is main chapter. In this first energy storage, battery based energy storage, and the second one is fuel cell based energy storage, and the third one is supercapacitor based energy storage. Fourth one is flywheel based energy storage, and the fifth one is hybridization energy storage. There in this chapter total 5 energy storage topics is there. Now I will explain one by one. I will start my presentation. Okay. Energy storage. These are the topics, main topics in the chapter. Introduction to energy storage requirements in hybrid and electrical vehicles. Next, battery-based energy storage and its analysis. The first one is a battery-based energy storage. Second one is fuel cell-based energy storage. Next, supercapacitor-based energy storage. Next, fourth one is flywheel-based energy storage. Fifth one is hybridization of energy and different energy storage devices. These are total 5 energy storage topics. First one is the batteries. Okay, battery is a electrochemical device. Okay, battery is electrochemical device. Battery, it stores energy in form of chemical form. Battery's definition is the battery is an electrochemical device that converts electrical energy into potential chemical energy during the charging. Okay, battery in charging mode, it converts electrical energy to chemical energy. During the discharging mode, the battery, it converts chemical energy into electrical energy. Okay, this is the main. Battery is a electrochemical device. Next, these are the cutoff voltage of a typical battery. Next, this is the waveform. In this waveform, I have 2 axes. One is, this is the time, discharging time. This is the cell voltage. X-axis discharging time. Y-axis cell voltage. Here, this dotted lines is the open circuit voltage. Open circuit voltage, the battery voltage, it maintains constant when connecting load. The battery will charging. This is the discharging curve. This axis discharging time ampere hour. Here the battery, this decline is the discharging curve. Here this is the cutoff voltage region. Here this is the cutoff voltage line. The cutoff voltage means, here the definition is there. Normally battery manufacturers usually specify the battery with ampere hour. Okay, battery manufacturers specify the battery with ampere hour. Ampere hour means here discharging time with this axis, x-axis, amperes hour, which is defined as the number of ampere hours gained when discharging the battery from fully charged to state until the terminal voltage drops to the cutoff voltage. Okay, this is the cutoff voltage, means this definition. Cutoff voltage here when discharging of the battery from fully charged. Okay, the ratio is the cutoff voltage region, fully charged battery to discharged ratio. Okay, that is cutoff voltage. Next, this is the discharging characteristics of lead acid battery. In this characteristics, this is y-axis, this is x-axis. X-axis here 0, 10, 20, 30, 40, here up to 100. This is the capacity of battery ampere hour. Okay, next this is the y-axis. In this y-axis, this is the voltage, cell voltage 1.55, 1.60, 1.65. Okay, 1.55 to 2.05. These are the battery voltage ratio 1.5 to 552 and 2.05 voltage. This is cell voltage. This is current rating ampere per hour. Next, the description here. The capacity will become smaller with large discharging current as shown in figure. Okay, in the circuit, the capacity means here the cell voltage will become smaller with large discharging current. Large discharging current means here 100 amperes, 70 amperes, 50 amperes, 30, 20, 10. These are our current rating. Okay, a large discharging current rate is shown in figure. Next, battery manufacturers usually specify battery with the number of ampere hours along with the current rating. Okay, battery manufacturers will design battery with the ampere hour along with the current rating. Current rating is this ampere hour, current 100 ampere, 70, 50. This is the current rating. Okay, design with the ampere hour with along with current rating. Here I have example also. For example, a battery labeled 100 amperes at the C5 rate. 100 amperes means the battery capacity is 100 ampere hour. Capacity is here 5 hours discharging time. The formula is discharging current 100. This 100 amperes, 100 by 5 means 20 amperes. The battery capacity is 20 amperes. Okay, the battery will discharge. The battery will discharge with 20 amperes load. The battery will discharge in 5 hours. Okay, this is the formula. 100 ampere hour. This 5 is the 5 hours. Okay, current capacity is 20 amperes. Like this, we will get. Okay, if hours increasing, example 10 hours, the battery capacity is 10 amperes. 10 amperes. 10 amperes will decreasing within 10 hours. Okay. Next, another important parameter of battery is the SOC. SOC is defined as ratio of the remaining capacity to the fully charged capacity. Okay, SOC is the state of charge. State of charge control. SOC is defined as the ratio of the remaining capacity. Remaining capacity means charging, how much percentage have in remaining to fully charged. That is, your example, a fully charged battery has an SOC 100%. A fully discharged battery has SOC 0%. If a battery have 50% charging, the SOC percentage is 50%. This is the SOC, state of charge control. If a battery have only 40% charging, the SOC is 40%. Okay, the ratio of remaining capacity to fully charged capacity. Here showing, if for example, the cell voltage is 2.2 to 2.05 volts. Okay, here the 100 amperes 10 amperes load, the capacity of discharging time will increasing. If you have more load means 100 amperes, the discharging time is very less. The battery will discharging very quickly. This is the discharging characteristics. The battery of 70 amperes, the battery comparing to this 100 amperes, 70 amperes load will better. Okay, like this. If you have less load, 10 amperes, the current. If you have 10 amperes, the duration of discharging time is more. Okay, next. The batteries, there are mainly 3 types. One is a lead acid battery, and the second one is nickel based batteries. Third one is lithium ion batteries. First, lead acid battery. The lead acid battery has been successful commercial product for over a century and is still widely used as electrical energy storage in automotive field and other applications. Okay, this lead acid battery is using from past century. Okay, successful commercial product, and with these batteries used in industries. Okay, and automotive field and other applications. The advantages of lead acid batteries. Its advantages are it's low cost and mature technology and a relative high power capacity and good life cycle. Good life cycle means the battery will discharging will the battery charging time is very less, and it operating charging discharging lifetime is more very more. That is a good cycle. Okay. Next, the cost is very low and mature technology and relatively high power capacity. These lead acid batteries operate high capacity. The advantages are attractive for its hybrid electrical vehicles, whereas high power is the first consideration. When we required, when we designing or when we required a high power electrical vehicles, mostly used lead acid batteries. This is the third point. Next, the materials involved in the lead acid battery. One is lead and the second one is lead oxide. Third one is sulfuric acid, or rather than rather low cost in when compared to their more advanced counterparts. Next, okay, the materials involved in lead acid, these three are lead, so first one, second lead oxide, third one sulfuric acid. These three materials used in lead acid batteries. Next point, the lead acid batteries is also have several disadvantages. The disadvantages are energy density of lead acid battery is low. Density is very low. Next, mostly because of the higher molecular weight. The weight of the batteries is more. Next, the temperature characteristics are poor. Okay, these three are disadvantages. Next, nickel based batteries. Nickel is a lighter metal than lead acid. Okay, this nickel based batteries lighter weight compared to lead acid batteries. These nickel based batteries have very good electrochemical properties desirable for battery applications. Next point, there are 4 different nickel based battery technologies. First one is nickel ion, second one is nickel zinc, third one is nickel cadmium, fourth one is nickel metal hydrate. These 4 are different types of nickel based batteries. Next, applications involved for lift trucks and mine locomotives and shuttle vehicles. Next, railway locomotives and motorized hand trucks. These are the different applications. Okay, locomotives and vehicles and railway locomotives. These are the trains. Locomotives trains. Here also mine trains and motorized handle truck. Okay, large trucks also used this nickel based batteries. Next, this nickel batteries has been considered as an important near-term choice for electrical and hybrid vehicle applications. These are some practical related information. A number of battery manufacturers such as GM, Onic, next GP, GS, Panasonic, and Shaft and Verta and Usha have actively engaged in the development of these battery technologies, especially for power and electrical vehicles and hybrid electrical vehicles. These are different companies, electrical vehicle companies used this nickel based batteries. Okay, these nickel based batteries used in electrical vehicle and hybrid vehicle. These are the some companies used this nickel based batteries. Next, lithium This third one is the lithium-based batteries. Next, third one is lithium-based. Lithium is the lightweight battery in all metals. Presently, very interesting characteristics from the electrochemical point of view. Okay, in comparing to this lead acid battery, nickel battery is very lightweight. Comparing to this nickel battery, lithium ion battery is very lightweight. Okay, next it allows very high thermodynamic voltage, which results in very high specific energy and specific power. For electrical vehicles, these two are very important. One is a specific energy, second one is specific power. Okay, so these battery have specific energy is more. In ultra capacitors, specific power is very more. Okay, there are two major technologies of lithium-based batteries. First one is lithium polymer. Second one is lithium ion. Okay, in this lithium batteries are two types. One is lithium polymer. Second one is lithium ion. Next point, the many battery manufacturers such as Soft and GS, Hitachi and Panasonic. Next, Sony. These all companies start usually this lithium-based batteries. Next, starting in 1993, SAFT focused on the nickel-based lithium-ion battery. This SAFT means this is a electrical company. This company, electrical vehicle company. This company started in 1993, using 1993 onwards usually this nickel-based lithium-ion batteries. Recently, SAFT reported the development of lithium-ion high-power batteries for hybrid electrical vehicles. Okay, applications with specific energy 85 watt-hour per kg and specific power 1350 watts per kg. Okay, recently implemented lithium-ion batteries for electrical vehicles. They also announced high energy batteries for electrical vehicles with about 150 watts hour per kg and 420 watts per kg. Okay, at 80% SOC, 150 ampere current rating and 30 seconds respectively. Okay, this this lithium batteries implemented this company SAFT. This total information related to batteries. Next, second energy storage system is ultra capacitors. The ultra capacitors mainly used for vehicle frequent stop and frequency running operation. Usually this ultra capacitors, the discharging and charging profile of energy is storage is very highly varied. These ultra capacitors here, the primary energy sources like internal combustion engine, fuel cells, and batteries work well as a continuous source of low power. However, they cannot efficiently handle peak power demands. Okay, these primary sources suitable for normal operating condition like in ICE means internal combustion engine, fuel cells, batteries. These three are operating well in normal condition. When we need uh, peak power demand, these three are not suitable. That time we use ultra capacitors in hybrid vehicles. Ultra capacitors delivers quick of energy during the peak power demands, then quick storage energy and captures excess power that is otherwise lost. Okay, the efficiently complement a primary energy sources in today's applications because they are discharging and recharge quickly. These ultra capacitors very fast charging and fast discharging purpose we are using uh, ultra capacitors. It charging fast and discharging also very fast. Okay, this ultra capacitors usually secondary source for hybrid vehicles. Otherwise, this ultra capacitors used for small small uh, small distance purpose like two-wheeler vehicles for hundreds only tens of kilometers vehicles. Ultra capacitors use it. Next, this is the basic principle diagram of a typical electrical double layer capacitor. Okay, here this is layer 1 and this layer 2. In this ultra capacitor have double layer. Okay, here this is the these two ends are two collectors. Okay, this one first one, this is second one. In this one is the polarized electrodes. This positive here, this in this one here we charger. Example, if we connect here battery, this positive terminal connected to here, next negative terminal connected to here. Okay, here this is the separator. This ultra capacitor principle, like the same capacitor charging. When we give external supply here, the battery is charging. When we need extra power, that time this capacitor will be charging. Okay, this is the positive terminals. This is the negative terminal. Okay, this positive terminal attracting negative terminals. This negative terminal attracting here positive terminals. Okay, if we apply more voltage here, total the capacitor will charges the energy. Next, the performance of ultra capacitors. This is the circuit. This is the way, performance of ultra capacitors. This figure discharging characteristics of ultra capacitor. In this in battery and ultra capacitor, the difference is in this battery have here ampere hours. In this ultra capacitor, it is discharging only in seconds, discharging time in seconds. Here cell voltage is 0, 0.5, 1 and 1.5, 2 and 2.5. This is the voltage rating of ultra capacitor. This is the time. Here time 0 to 20, 20 to 40, 40 to 60. This is 60, the 60 seconds. 60 seconds means 1 minute. And here 120 seconds means 2 minutes. The capacitor will discharging in 2 minutes. The current capacity is 600 amperes, 400 amperes, 300 amperes, 200 amperes, like this. When we connected, when discharging capacitor with high current, the discharging time is very less than 20 seconds. When discharging current is less means 50 amperes, the capacitor will take discharging time 120 seconds, 120 above 120 seconds. 120 seconds means 2 minutes. Okay, next, here where the I is the discharging current, which is a function of time in real time. This is a real time waveform. This is Maxwell discharging characteristics of Maxwell 2600 farads ultra capacitor as shown in figure. This is the Maxwell company designed capacitor characteristics. Next, at different discharging current rates, the voltage decreases linearly with discharging time. Okay, here voltage is decreasing linearly with the discharging time. At a large discharging current rate, the voltage decreases much faster than the smaller current rate. Okay, in this waveform, the voltage is decreasing very linearly. Okay, ultra capacitor and battery differences. Ultra capacitor discharging in seconds, battery discharging in hours. Next, third energy storage system is flywheel. Okay, ultra speed flywheel. Next, the use of in this flywheel, it stores energy in form of this is circuit diagram. This is flywheel, basic structure of flywheel. In this flywheel, it stores energy in this wheel. Okay, storing energy in this wheel. Okay, in the energy storage in the form of kinetic energy. Okay, this wheel shaft connected to the this generator. In this generator, have rotor of electric machine. This is the rotor of electric machine. This is stator of electric machine. These are the three-phase external terminals connected to the outside. These are the magnetic bearings. Okay, here vacuum. This is this upper and lower are the magnetic bearings. This is the wheel. In this wheel, it stores energy in form of kinetic energy when charging time. When discharging time, this wheel it act as a generator. Generator means turbine. Okay, this wheel it rotate this machine rotor. These are the some points. This flywheel technology not new. Okay, this flywheel technology more than 25 years ago introduced. Okay, the Orl Orlikon next the engineering company in Switzerland made first passenger bus powered by a massive flywheel. Okay, next this flywheel which is weighted 1500 kgs and operated at 300 rpm was the recharged by electricity at bus stop. Okay, this is 25 years back. This flywheel technology introduced. The first flywheel weighted 1500 kgs and operated 300 rpm. Now the traditional flywheels operated with thousands of rpm. Okay, next the concept of ultra high speed flywheels appears to be a feasible means of fulfilling the finite energy storage requirements for electrical vehicle and hybrid electrical vehicle applications, namely high specific energy, high specific power. These are the main advantages of this flywheel technology: high specific energy, high specific power, and long life cycle. Next, maintenance free. Okay, these are the main advantages of ultra flywheels. This is the ultra flywheel circuit diagram. This is the example vehicle. This is the IC internal combustion engine. This is the continuous variable transmission. This is electric motor, fuel tank, and batteries. Here connected electrical flywheel. Okay, this is the website link. This website link. This company introduced this designing. Okay, here these two are wheels. This is the flywheel. Okay, flywheel connected. When braking mode, the flywheel it stores energy, kinetic energy in this flywheel. Okay, when our normal operating condition, the flywheel it rotating motor. Okay, when regenerative braking, the braking condition, flywheel it stores energy. Next, fourth one is the last energy storage system. Fuel cell like a battery. The difference between fuel cell and a battery. This is the fuel cell diagram. The difference between the fuel cell and the battery. A battery is a electrochemical device. It stores energy in form of chemical energy and it produce electrical energy. This fuel cell is not store any energy. This fuel cell it produce continuous energy. Okay, this fuel cell fuels are input. One is hydrogen, second one is air, H2 and O2. Okay, in this is the anode, this is the cathode, two electrodes. Okay, this is the input side, excess fuel going to this side. This is the input fuel, the hydrogen. If you have excess fuel entered in this fuel cell circuit, this is the output side. Excess fuel going to output side. Here also air, this entered here. If you have excess air entered, this is the output. Okay, this total chemical reaction will happen. Reaction will do in this circuit. Okay, finally electrical current will produce like a same battery. But the difference between battery and fuel cell, main difference is battery and fuel cell. Battery is a energy stores and charging and discharging. This fuel cell it generate continuously voltage, continuously power. Okay, fuel cells can produce electricity continuously for as long as fuel and oxygen supplies. Next, the first fuel cell were invented by Sir William Brown in 1838. Okay, these are some points. They produce electricity and heat as long as fuel supplies. Next, fuel cell consists of two electrodes. One is a negative electrode is anode, and the second one is positive electrode is cathode. Okay, shunt which is around the electrolyte. Next, fuel cell such as hydrogen is fed to an anode and air fed to the cathode. These are the some description about fuel cell. This is fuel cell electrical vehicle, hydrogen fuel vehicle. Here this is these two are wheels here, more connected to electrical traction motor here. Next, this is the power converter, DC to DC power converter connected to here. Next, this is the thermal system cooling. This is thermal system cooling. Next, here this is the fuel tank. This fuel tank filled with hydrogen. Next, this fuel cell stock. Okay, fuel cell stock here. This in this here, this tank will store hydrogen. Here, fuel cell stocks. This means fuel cell. This is one. This fuel cell input coming from this fuel tank. This is the secondary source. Secondary source we have here. This is a battery. This is one is primary source battery. This is the secondary source is fuel cell. This is fuel filler. If we need charging battery, fuel will fill to this. If we need to we need to charge this battery, this is source one. If we need to fill hydrogen, fuel will give input here, hydrogen. Okay, this is the hydrogen fuel cell vehicle. This is a hybrid vehicle. Okay, this is the reference website. Next, this is the hybrid energy storage system. Hybrid energy storage system have this in the slide have three diagrams. One is A and B and C. This is the first. This is high energy, high specific energy. One, high specific power storage. Two, here two sources. High power demand. When have high power demand, source one and source two supply to the load. When we need low power demand, supply one will send it to the load and supply two recharging with charging with supply one. When we have required when vehicle operating in braking, that time source one and source two will discharge charging. Okay, this is the third one is the regenerative braking. Regenerative braking time, load to power converter and power converter to high specific energy and power converter to high specific power, the negative power. These lines are primary power flow. This second one is the dotted lines are the secondary power flow. These three are three high power demand. Two sources supply to the load. Low power demand supply one sends to the load and supply two recharging. In regenerative braking, supply one and supply two charging. Okay. Okay. Thank you. Thank you for watching this video.